All right, welcome to this explainer. Today, we're zeroing in on an absolute game changer in UI development. We are looking at the incredible versatility of the B4XDaisyIconButton component. Seriously, if you've ever found yourself just drowning in a sea of slightly different button files, one for a solid color, another for an outline, one for a loading state, maybe another for a circle, you are going to absolutely love this. We're going to look closely at the source code and some great visual examples to see how one single component can literally do the heavy lifting of dozens. Okay, let's dive into this. Here's our agenda for this visual feature tour. First up, Section 1, the ultimate icon button. Then Section 2, styles for every scenario. Moving on to Section 3, shapes and sizes. And finally, Section 4, states and custom icons. Starting with Section 1, the ultimate icon button, a UI wardrobe showcase.
To define it strictly based on the source code, the B4XDaisyIconButton is a single B4X custom view class. Basically, think of it as a highly versatile module that can put on entirely different outfits. The real magic here is that it completely centralizes styling, geometry, and state management. So, instead of having dozens of static, hard-coded button variations just cluttering up your project, you have one intelligent component. You simply pass its string tokens right through the designer properties, and boom, it transforms itself. It entirely replaces the need for maintaining separate classes for every minor visual tweak.
Okay, Section 2, styles for every scenario. Dressing the button.
Take a look at this vibrant array of buttons here. Notice the distinct visual aesthetic of each row. Up at the top, we have those bold, solid buttons. Right below that, you can see the gentle, translucent backgrounds of the soft style. Then we've got the crisp outline buttons, the kind of playful dash borders, and finally at the bottom, those minimalist ghost buttons, which just blend right into the background until you actually interact with them. And this brilliantly illustrates the power of a centralized UI module. You are looking at an incredible variety, all generated by the exact same underlying code.
So how do those visual rows actually work under the hood? Well, it all comes down to the DNA of the buttons, specifically the designer properties. The visual rows we just saw map directly to two main string properties found in the B4X designer code. First is the style property. This dictates the overall look, and it supports string values like solid, soft, outline, dash, ghost, and link. Second is the variant property, which handles semantic colors. So instead of hard-coding messy hex values everywhere, you just tell it, hey, I want a primary, secondary, or accent button, and the class resolves the correct palette color automatically. Pretty slick, right?
Moving right along to Section 3, shapes and sizes, the geometry of UI.
If we compare the top two rows, we're looking at solid square versus solid circle buttons. Both rows are utilizing the exact same solid style and the exact same color variance across the horizontal axis, but structurally, they are completely transformed. Let's look at how the code actually manages this structural shift. Now, what's really interesting about this is how the code specifically handles the shape property. When the shape is set to square, the component pays close attention to a secondary property called rounded. This lets you apply specific custom corner borders, like, say, a medium radius or a large radius. But, and here's the kicker, when you set the shape to circle, the component executes a hard override. It forces the geometry to be a perfect, rounded full circle, and it completely ignores any custom border radius you might have tried to pass to it. It's a really smart failsafe that keeps your UI design system totally consistent.
Let's see how this builds into overall component sizing. Check out the sizes rows here. You can clearly see both primary circle and primary square buttons scaling uniformly, all the way from extra small up to extra large.
And this table reveals the exact math making that scaling happen so smoothly across any device screen. The component uses specific logic subroutines resolve button size dip and resolve icon size dip to translate those simple string tokens into device-independent pixels. For the button container itself, XS equals 24 dip. Then it scales up steadily by 8 dip per size, maxing out at 56 dip for XL. Simultaneously, the icon inside scales perfectly as well, moving from 12 dip at extra small to 20 dip at extra large. This dual resolution absolutely guarantees the icon is always perfectly proportioned within its parent button, no matter what size token you use. Which means no more squinting at off-center icons that, let's be honest, drive developers crazy. Finally, we are on Section 4, States and Custom Icons, Dynamic Interactivity.
Looking down at the bottom half, we can see exactly how the static button transforms. Notice the active state row, which gives really clear visual feedback. But more impressively, look at the loading state row. The icons are entirely replaced by perfectly centered, color-matched loading spinners. And right at the bottom, the different icons row proves how seamlessly various SVG assets like play buttons, little hearts, check marks, bells, and gears just swap right into the component without breaking the layout whatsoever.
Let's clearly define exactly what that loading property does under the hood, because it's not just a visual trick, it's a Boolean property that acts as a true 2-in-1 lock. When you set loading to true, it simultaneously reveals that animated loading spinner while functionally disabling the button's click behavior right at the code level. It saves you from having to write annoying custom logic to prevent a user from, double submitting a form while an action is processing.
Which naturally brings us to the ultimate question for any interactive component. What exactly happens when you click the button? How does the component decide whether to trigger an event or just ignore the user? Well, the underlying event logic is beautifully simple, and it's all handled in the mbase_click subroutine. When a click occurs, the code runs through a very strict sequence of safety checks. Step 1 is the clickable property set to false. If yes, it stops right there. Step 2 is the disabled property true. If yes, it returns. Step 3 is the loading property true. Again, it returns. So the absolutely crucial point here is that only if all those states are clear does it finally move to step 4, where it safely forwards the button's tag payload straight to your callback subroutine. And brilliantly, clicking the actual SVG icon itself or clicking the loading spinner does absolutely nothing. Those clicks are ignored and everything is routed safely through that root base view.
To sum it all up, the B4XDaisyIconButton is proof that complex UI requirements don't actually need complex code scattered all over your project. You can achieve really incredible visual flexibility and robust interaction safety with just a single modular component and a few clever string properties.
I want to leave you with this thought to ponder as we wrap up. If a single component can handle every style, every interactive state, and every geometric size we've shown today entirely through simple string tokens, how much redundant code could you eliminate from your next UI build? Thank you so much for joining me for this explainer, and hey, happy coding!